If you are self-hosting more than a handful of applications, then probably you have already run into this problem. Every new service wants its own database container, and nowadays it is usually Postgres. And before you actually notice it, you are running way more Postgres instances than you actually need, each one quietly eating up memory and storage you never planned for. But a single Postgres instance that is properly configured can handle every single one of those applications. Each application simply gets its own database with its own dedicated user and permissions, so their data stays completely separated, even though they are all living inside the same instance. You get the same reliability, a fraction of the overhead, and full control. Also, there is another problem. A running database cannot simply be backed up with disk snapshots or with tools like Duplicati or ResTick. It needs a proper dump to be truly safe. And once every application lives inside one Postgres instance, that entire backup problem shrinks down to just one database to protect instead of many. So in this video, we are self-hosting Postgres 18 with Docker, built from the ground up, with a configuration and best practices that you will need for all your self-hosted services. And it does not matter if you are starting fresh or already running an older version of Postgres. Once this instance is up, the next videos will walk you through backing it up properly and migrating your existing data over from any previous setup using that same backup tool. So you can follow along no matter where you are starting from. Let's begin by preparing the configuration files. So let's go ahead and create a dockercompose.yml file. Inside this file, we will be defining our services. And under this, let's define our Postgres service. Now we need to set the image. For that, let's head over to Google and search for the Postgres Docker image. And you can see the official image page on Docker Hub. Let's go ahead and open that link. Now we can copy the image tag from here. But for databases, it is recommended to use fixed version. So if you look at the tags down here, the latest tag points to version 18.4. But I prefer using the Alpine image instead, because it is much smaller in size, and it is also equally capable. Now, if we check the Alpine image tags for version 18.4, the most updated one is Alpine 3.24. So let's copy this version number first. Then, on the Tags tab, we need to search using the tag filter, so let's paste the image tag in there. Once the search results come up, we can copy the entire image tag from here and paste it into our Docker Compose file. With the image set, let's move on and give our container a name. For the container name, I will go with Postgres. Now let's move on to setting up the environment variables for our Postgres service. We need to add our first item, which is Postgres user. Let's set it as an environment variable using the $sign and curly braces, and inside that we can copy the same variable name. Next, we need to set the password. Let's paste the same variable name again, then modify it to say Postgres password. And once again, we will create an environment variable and copy variable name inside it. We will do the same thing for PostgresDB. Now we need to create a .env file, where we will define our Postgres credentials. Let's copy the variable names directly from the Docker Compose file. I will set the user and the database name to Postgres. For the password, make sure to provide a strong password, since this will protect access to our database. Let's head back to the Docker Compose file, and under Environment, we need to add a new variable for TZ and set it to the time zone variable. Then similarly, let's also add pgTZ and set that to time zone as well. The reason we need both is that TZ sets the system-level time zone for the container itself, while pgTZ specifically controls how Postgres displays and interprets timestamps, which means the two can behave differently if they are not kept in sync. We can also define all of these configurations inside the .env file. So let's paste time zone in there, and let me set it to my time zone. Then, back in the Docker Compose file, let's add another environment variable called Postgres initDB arguments, and set it to --data checksums. This helps Postgres detect and flag data corruption early, before it becomes a bigger problem. Now let's define our ports, and we will expose port 5432 on the host side, and also port 5432 on the container side. For volumes, I will map a directory from this current location, and I will call it pg_vol. Then on the container side, we will map it to /var/lib/PostgreSQL. If you have checked my previous video, where I covered Postgres 17, the path on the container side was slightly different, pointing to a data subfolder. But starting with Postgres 18, that path has changed. So if you are upgrading from version 17 to 18, then make sure you are using the updated one. Next, let's add security opt and set no new privileges to true. This prevents any process inside the container from gaining additional privileges beyond what it already has, which adds an extra layer of protection. Then for shared memory size, let's set that to 256 MB. This will limit the Postgres instance from overutilizing the shared memory on our host. Now for our Postgres service, we should also define a logging section. Let's set the driver to JSON file, and then add an options parameter inside that. Here we can set the max size for a single log file to 10 MB, and limit the max number of files to 3. This keeps our logs from growing indefinitely and eating up disk space over time. Since a lot of other services will depend on this Postgres instance, it is a good idea to add a health check as well. For the test, we will use cmd shell, followed by pg_isReady-u. Then add a $sign and copy Postgres user variable from above. This will replace this variable with our actual Postgres username. Then let's set the interval to 10 seconds and timeout to 5 seconds. I will also set the number of retries to 5. Finally, for the restart policy, I will set mine to unless stopped. Now that our configuration files are ready, let's go ahead and deploy the Postgres Docker service. For that, let's open a new terminal. On this device, we already have Docker installed. To deploy our service, let's type docker compose up-d, and you will see our Alpine Postgres image is being pulled. Once that is complete, you will see the volume directories are created. But you cannot access anything inside this directory unless you are checking as a root user. Now to test if our Postgres instance is working as expected, let me head over to pgAdmin. Before I test anything here, I will create a new group for this instance. Let's right-click on an existing group, then go to Create and click on Server Group. I will name it Dev and click Save. This will create our Dev server group. Now let's right-click on Dev, then go to Register and click on Server. Let's give this server a name. I will call it Postgres. Then let's head over to the Connection tab, where we need to fill in a few details. For the host, we need the IP address of this device. We can find that in VS Code on the bottom left side of the screen. Let's fill it in here. For the username, we need to fill Postgres. For the password, let's head over to our .env file, copy the password, and paste it in here. Let's also enable the Save Password option so that we do not need to enter it every time. Once that is done, let's click Save, and that will register our server. If we expand the server item, you can see the new Postgres user and database that we defined in the Docker Compose file have been created, and they are now listed under Databases and Logging Group Roles section, which means everything is working as expected, and we have a running Postgres database service. Now, let me show you one trick. I like to create users and databases using a script so that I can provide those to other Docker services as needed. For my homelab, I usually create a file and name it something like db.secrets.yml. Then add all the details for the users, passwords, and databases in there. I also make sure to add any file containing .secrets.yml to gitignore so that these files are never committed. This approach helps me to create databases and users for multiple applications at the same time, which is especially useful whenever I am setting up a new application. Let me go ahead and copy the scripts into this directory. Inside it, I have a few files that reference our db.secrets.yml file. Now let's head over to the terminal and navigate inside the scripts directory. Then execute our create user and database script. This will create all the users with their respective passwords, along with their databases. Even if we run this multiple times, it will simply skip over any users or databases that already exist. This also comes in handy whenever I am setting up a new application that needs database access. If we head back to pgAdmin and check again, you can see that all the databases and users have been created. You can definitely create those manually from the pgAdmin UI or through Postgres CLI. But if you think that using script for this is a good idea and you feel like you need that, then let me know in the comments section. If more than 10 people comments for the script, I will definitely share it, along with usage details. With that, you now have a reliable and robust setup for a Postgres database to handle all of your applications in your home lab. If you think this video helped you, make sure to hit the like button and hit the subscribe button for more such content. If you run into any issues along the way, drop a comment below. I always read and reply to all of them. You can also join our Discord server, and if you are struggling with something or need help urgently, we have a great community there that is always happy to help. Now that you have a database running, backing it up is the next most important thing to think about. Otherwise, all the data from any application that relies on this database will be at risk. So to see exactly how I back up my databases, make sure to check out my next video, where I will walk you through the full setup and the best practices around it. Thanks for watching, and see you in the next one.